In this example, we're going to calculate the number of moles in 50.0 grams of fluorine. Now remember what the mole concept allows you to do. It allows you to count atoms or molecules. This is an incredibly important concept in chemistry. You've got to get this. If you don't get this, you'll be lost in most of the remaining modules. So let's understand what the mole allows you to do. Here I've got 50.0 grams of fluorine. That's something that could easily be measured in the lab. I'm going to use that information and the concept of the mole to actually count the number of atoms of fluorine in that sample. Now that's pretty impressive, and that's what the mole concept allows you to do. Let's get to it then. If we're going to determine the number of moles in any sample, we need to look at the periodic chart. In this case, we're talking about a sample of fluorine, so let's look at fluorine's entry in the periodic chart. Here it is. There's a 19.0 under the F. What does that mean? Well, it actually means two things. First, it means one fluorine atom has a mass of 19.0 AMUs. That's the first meaning of that 19.0. But it also means something else. It also means that it takes 19.0 grams of fluorine to make a mole. Okay, the first meaning of this 19.0 is easy to understand. It just tells us the mass of the atom in atomic mass units, and that's a unit for mass. So it's just telling us the mass of the atom. What does the other one mean? It takes 19.0 grams of fluorine to make a mole. This tells you a conversion relationship between grams and moles. It tells you that 1 mole of fluorine is the same as 19.0 grams of fluorine. So this number serves as a conversion relationship between moles and grams. We look at the periodic chart, we look at the mass of the atom, and that number also gives you a conversion relationship between grams and moles. In this case, it's telling you that 1 mole of fluorine is the same as 19.0 grams of fluorine. All right, well, if that's a conversion relationship, then doing the conversion is pretty simple. We take the number we have, 50.0 grams of fluorine. We put it over 1 to make it a fraction. Then we multiply by 1. But the expression we're going to use for 1 comes from this conversion relationship. All right, now I want grams of fluorine to cancel. So 19.0 grams of fluorine is going to have to go on the bottom of this fraction. That leaves 1 mole of fluorine on the top. All right, so my conversion is 50.0 grams of fluorine over 1 times 1 mole of fluorine over 19.0 grams of fluorine. When I do this, the grams of fluorine cancel, and that leaves moles of fluorine. So when I do the math, I find out that 50.0 grams of fluorine is the same as 2.63 moles of fluorine. The ability to convert between grams and moles, and also the ability to go the other way, from moles to grams, is an incredibly important skill to master. If you don't master this skill, you'll be lost for most of the rest of the course. So get this skill down now. All right, I want to make one point about significant figures. I reported my answer here to 3 significant figures. That's easy because 50.0 has 3 significant figures. Usually in conversions, we always preserve the original number of significant figures. If I start with 3, I should end with 3. That's not the case with this kind of conversion. With this kind of conversion, the conversion relationship depends on a measurement, the mass of the fluorine. So, in all of the conversions between moles and grams, or going the other way, from grams to moles, we have to worry about significant figures. The term 1 mole will be considered exact. However, the number of grams it takes to make that mole is not exact. It has error in it. So we have to count significant figures. So 19.0 has 3 significant figures. That's the same as 50.0. So my answer has 3 significant figures. If my mass had only been 2 significant figures, and if it had been 19 grams rather than 19.0, then I could have only reported my answer to 2 significant figures. So in these conversions, pay attention to significant figures.